In this lesson, we're going to cover the basics of increasing hash security. Now, before we talk about how to increase hash security, we probably should focus first on two common types of hashing attacks that are used by threat actors. These are the pass the hash attack and the birthday attack. Now, first, we have the pass the hash attack. Hashing is a commonly used method of storing passwords inside of our systems, and therefore, if the hash digest or hash value of that password can be obtained by an attacker, they can try to break into your network using those hash credentials. Now, the pass the hash attack is a hacking technique that allows an attacker to authenticate to a remote server or service by using the underlying hash of a user's password instead of actually associating the plain text password that you normally have to log in with. Now, if an attacker is able to sniff that hash or steal it some other way, they don't actually need to brute force the hash to try and get that clear text password of your giving user account. Instead, the attacker can simply reuse the hash of that arbitrary user account as they go and authenticate against the remote system, and they can then impersonate the user that way. In other words, from an attacker's perspective, hashes are functionally equivalent to the original password that they generated, and this means they don't actually need to get the actual password for your account to log in as if they were you. The pass the hash attack is really difficult to defend against because there are so many possible exploits inside of the Windows operating system, as well as the applications that run on top of it. Any of these can be used by an attacker to elevate their permissions and then be able to pull off the credential harvesting or hash harvesting that they can then use in a further attack using the pass the hash technique. Also, only one machine in a Windows domain needs to be misconfigured or missing a critical security patch for that hacker to be able to find their way in and be able to execute this pass the hash technique. Now, there are many penetration tools out there like Mimikatz that will give you the ability to automate this process of harvesting the hashes and conducting the pass the hash technique. To prevent the pass the hash attack, you should ensure that only trusted operating systems are allowed to connect to your servers, that your Windows domains have their trust set up properly, and that workstations are all going to be patched and updated, as well as making sure your multi-factor authentication is being used properly in your network, and that all user accounts have been set up to use the concept of least privilege. Now, the second type of attack I want to cover is what's known as a birthday attack, and the birthday attack occurs when the attacker is able to send two different messages through a hash algorithm and then get the same identical hash digest. This is what we call a collision, and in the case of a birthday attack, we actually are trying to create collisions. Now, this attack gets its name from something known as the birthday paradox, which says that if you have a random group of people, the chances that you're going to have two people in that group with the same birthday is pretty high. Now, when I teach this course in person to a group of 30 people, most of the time, two people in the class are going to have the same birthday based on the same month and day, because there are only 365 days in a year. So, if you actually do the math on this, you only need 57 people in a room to get a 99% chance of having two identical birthdays. Now, with 23 people in the room, your odds are about 50-50. And that's why in a class with about 30 students, more often than not, we have identical birthdays, because that puts us somewhere in the 70 to 80% range based on the underlying math. Now, in the world of hashes, two identical hash digests are called a collision. And if an attacker can find two identical messages with the same hash, they can use this as an attack against your system. For example, let's say that I found a match to your password's hash, that I can then use that to bypass your authentication system, even if I'm entering in the wrong password, as long as that password has the same hash value. For this reason, we want to make sure we're using hashes with long output digests, so we start using things like SHA-256 over MD5, because this will significantly reduce the amount of collisions and the effectiveness of a birthday attack. So, how else can we increase the strength of our hashes, especially when using them as part of our password security? Well, one of the first things we can do is use something known as key stretching. Now, key stretching is a technique that's used to mitigate a weaker key by increasing its effectiveness and thereby increasing the time needed to crack that key. When you stretch a weaker key, the weaker key is run through an algorithm to create a longer, more secure key than what would normally be used. Many systems are going to utilize key stretching to increase the security they provide, including systems like Wi-Fi protected access, Wi-Fi protected access 2, pretty good privacy, bcrypt, and others, which all use key stretching to mitigate a shorter key's inherent weakness. Second, we have salting. Now, salting involves the addition of random data, which we call a salt, to the password before it undergoes a one-way cryptographic hash function. This process ensures that even if two users have the same password, their hashed outputs will be different because they're using different salts. Now, by doing so, salting amplifies password security and thwarts various password cracking strategies and techniques like dictionary attacks, brute force attacks, and rainbow table attacks. Dictionary attacks happen when an attacker tries every word from a predefined list, and this becomes much more challenging because the salt is going to alter the hash outcome for those commonly used passwords. Similarly, Brute force attacks, where every possible password combination is tested, becomes a much more time-consuming process because of this salting process. And finally, we have rainbow tables, which are pre-computed tables for reversing cryptographic hash functions. And these are rendered ineffective against salted hashes because the added salt forces the attackers to compute a new table for each and every salt value, making this type of attack much more impractical. The third thing we have to use is what's known as nonces. Now, utilizing a nonce is a strategic way to enhance the security of potentially vulnerable passwords. A nonce, which stands for number used once, is a unique, often random number that's going to be added to the password-based authentication process. The primary function of a nonce is to ensure that even if the attacker is able to get your password or its corresponding authentication data, they simply can't reuse it for unauthorized access. By adding this transient number to the authentication sequence, your resulted hash data is going to change every single time and make it significantly harder for a cyber adversary to exploit stolen credentials. This ephemeral approach is going to add an additional layer of security, especially in systems that are vulnerable to replay attacks where the attacker attempts to resubmit captured data for unauthorized access. Finally, your systems need to be configured to limit the number of failed login attempts allowed for a given user. This will help to prevent password cracking attacks against your accounts. Normally, you want the number of incorrect passwords entered before locking out the account to be set somewhere pretty low, like 3. That way, if somebody enters the password incorrectly 3 times, that account will automatically be locked. Yes, this can become painful for your users if they accidentally enter the wrong password too many times, but it does increase the security drastically, and it does help to slow down an attacker who's trying to guess the user's password and break into your systems. So remember, hashing can be attacked through the use of pass-the-hash techniques to reuse a password without cracking its hash first, or by using the birthday paradox or birthday attack to create known collisions. To prevent these types of hashing attacks, you should increase your security of your hashing system by using key stretching, nonces, and limiting the number of incorrect login attempts. Key stretching is a technique that's used to enhance the security of stored passwords by applying a hash function multiple times, and therefore making brute force attacks much more time-consuming and computationally expensive for an attacker. Nonces are unique values, often random numbers, that are going to be used once inside of a cryptographic operation to prevent replay attacks by ensuring the repeated transactions produce different outputs. And limiting the failed login attempts is a security measure that restricts the number of incorrect login attempts that a user can make within a given time frame, and the goal here is to deter attackers from continually guessing a user's credentials. By implementing these techniques, our hash digest and their associated data can be better protected from threat actors who may be targeting your enterprise networks.